I believe I'm making a video, a draft physics video production. And of course the microphone is in the wrong place, so I'll make some crappy noise to move it. There, that's probably better. Anyway, whatever. Alright, so context before beginning, probably should add some. Alright, so I see this as analogistic to the old days, a couple 300 years, 200 years ago, where there's this debate because, you know, a new theory shows up, evolution, and it sort of explains in a real simple way everything, you know, about why humans are the way they are, why all the animals are the way they are, why the earth looks the way it does, you know, that this thing evolved. That's the simple answer. And that we don't need any of these silly complex answers of gods and magical things. So I would argue that conventional physics has bought a whole bunch of storytelling and created a narrative where they have to explain all kinds of mystical beasts like the entanglement and the dark stuff and the that's not even where really the core of it, the mistakes made. Okay, and they made a ton of them, misidentifying plus and minus, all that kind of stuff. And they didn't fix, they have no will to fix any mistakes ever. As in religion. They just have to take everything as, yes, this is, you know, somebody believed it in the past, therefore we have to believe it in the future. And they can't let go of any of it. So they have all kinds of constructs. You know, there's 4 different kinds of forces, even though they all have so much in common. We're going to pretend they're 4 different kinds of things. We're going to accept ideas like bent space as an answer to something, and then we'll say, oh no, virtual photon is the answer for the same exact phenomenon. Really tiny differences. It just doesn't, you know, silly, convoluted. Now they got 400 particles. They have no role for them to play, really. No evidence that they truly exist. They have a lifespan of milliseconds. It's just all magical, way too complicated nonsense. It's a religion. It's a story of nonsense. Just a bunch of, you know, the creatures, a bunch of complex explanations for simple things. So it's like making up gremlins or, you know, fairy hate monsters who don't like you and they're ruining your crops, or some kind of voodoo. And it's just full of all that kind of garbage, and that it can be understood, it can be modeled as being something simple, natural selection. So I've proposed that the simple answer is that there's momentum in the universe in the form of what we could call a force. And it's just the fact that there is stuff in the universe moving the speed of light in directions. And there's just a sea of it. And it's moving in all kinds of directions. Okay, there's a ton of it, and it's all moving about, banging into each other. And the only distinction between the stuff I'm making green and the stuff that's yellow, as you call it yin yang, you can call it, doesn't really matter. It's just got a difference, okay, a very subtle difference. And the fact is there's 2 kinds of real particles in the universe, in the sense of boats, you could say. Or you could just say ping pong paddles and ping pong balls. You can reduce this, you know, simply. And the only difference here is one's got this designation of a positive and a negative, or you could say one's a north kind of force and one's a south kind of force. And then all you need to understand is that these 2 things, when this stuff hits them, it changes their momentum, and it changes where this stuff was going. So if it was going this way, it might be going that way, you know, when it leaves, and this will be going some other way, depending on which way it was already going. So, again, you could just reduce this to ping pong paddles with a bunch of ping pong balls coming in from the universe, and there's one's trapped between them, and it just reacts differently depending on which ping pong ball hits, a yellow one or a green one. and they have an inverse reaction, and that essentially creates magnetism and electricity and all that stuff. So this is charge, you could say. The fact that these two things are capable of reacting differently to yellow and green is charge, and charge makes electricity and magnetism. And that's what's creating everything. There's only this one kind of force. It can get trapped, as I've pointed out, the paddles. If the two paddles are green and you have green caught between them, it'll constantly reflect, which gives you this ability to create tremendous pressure between two objects. And likewise, the other stuff deflects, the motor force, you could say. So if it comes in, it doesn't get trapped, and that can create tremendous attraction between objects. Like if this was a plus object, so if they were inverse in their function, and you inverse the force, you can create an awful lot of attraction, because you're changing the outcome and preventing there being any force between them. And that would essentially be the part that we see sort of as gravity. It's a little more complicated. Gravity is actually just this, and you have all the magnets pointing in different directions. So you make a bunch of magnets, and if you have them all pointing in different directions, you end up neutralizing their charge function, gets diluted into a neutral. You smash the yin and yang together, but you still end up with this fact that this thing is going to change what this thing sees of the universe. It's still going to create an effect, in the sense that stuff that was heading right for this guy isn't going to get to him because there's somebody else in the way, and vice versa, creating an obvious kind of shadow. So all you need is two kinds of force and two kinds of matter and two kinds of interactions, and you can explain everything in the universe. You can explain all these functions of the universe, and you don't need different kinds of forces. You don't need bent geodesics and virtual photons and entanglement and all of this mush, that story full of whatever, bears that eat porridge and all kinds of fantastic explanations. This will do it. These simple elements. This is natural selection versus their story of this complex functions, that magical levels that things jump into and all that kind of mush. There's only one force. Maxwell was halfway to the right answer by saying that electric and magnetic are doing something so similar, and then they bisect the speed of light to essentially describe these two forces. But no, it's just one, and the two manifestations just have to do with whether you put two of these objects right next to each other, which we can't do with charges because it's on the surface, not the stuff itself. But in nature it happens, and the atom creates these little magnets. And if you put a bunch of little magnets together, you get a big magnet. And so this charge function explains magnets. I mean, there's nothing they think it's a big mystery that, you'll get a Nobel Prize if you find a magnetic monopole. Yet the electron and the proton are doing exactly what magnetic monopoles would do. That's exactly what they would look like. If you could write a description of what the magnetic monopole would look like on the elemental level, this is the elemental level of monopoles. And I don't know. And I can only sit here and wonder how you can't understand. I mean, it's so obvious. Even just that simple argument that they keep saying it as if it's some mystery. Where are these magnetic monopoles? Where's the source of magnetism? When it's right in front of them, it's obvious, it's glaring. And yet I have to somehow make an argument that there's some mystery somewhere. There's no mystery. But it's because they've already said this is an electric monopole. They can't understand that, yeah, it's doing both things. That's right. Yeah, it's one force, one real mechanism. So again, the only difference between the force is, you can take this stuff and if I put it at if I can find a way to shoot it at a specific frequency, you know, where they're all the same distance from each other, okay, that's a photon. If I create a mechanism like this little magnety thing, okay, that basically functions to say anything that comes in green will end up reflecting or being emitted out of one end, and anything that comes in yellow will be emitted or reflected in the other direction. Simple rule, nothing complicated. Stop doing that. Stop doing that, I requested. So all I've done is segregate it. So if I can, gotta buy a new cable, find one or steal one or whatever you do when you need a new cable. So if I put it at a frequency, I've created a photon. If I segregate it for its color, its charge, you know, however you want to look at it. If I segregate it, I've got magnetism. If I mix it, you know, essentially, you know, I'll end up with gravity. And what's the fourth one? Oh, then you know when you get into these, the scenario of their storytelling about the inside of the atom, and what they call the strong force, the strong nuclear force. Well, there's no mystery to that, in the sense that if you just put the electron in the neutron, if you make a neutron, okay, which is essentially they already have figured out, and good on them for figuring it out, that a neutron is just one of these pair very close together, essentially a hydrogen atom just compressed, and you put another proton in there, you have a scenario with all the force that would reflect ends up leaking out of the electron, so there can't be any reflection between these two paddles, because you have a paddle in between that deflects the force that would bounce back and forth between them. And so there isn't really a strong force, it's the absence of force. But it explains why you can take two things that hate each other that would create a lot of reflection, and you just put a little bit of yin, or you put a little bit of yang in between two yins, and yeah, you'll be able to get your yins really close together. Alright, so anyway, that's probably enough of a context. But there's simple, you know, there's simple explanation, and then there's this convoluted, complex mush where they would never start over, never say, let's, you know, let's just sit down and take what we do know and take out the bits, the gremlins, the stuff that really doesn't make any sense. So they got this idea of a Bohr model, you know, whatever, more than 100 years ago or 100 years ago. You know, this idea, because, you know, the solar system uses gravity, they're going to put gravity on that level, and even though they say it's not gravity, it's charge, you know, they got stuff whipping around, other stuff, very complex, you know, 400, you know, 1,000 meters per second, this little electron is buzzing around, and then they say that somehow that makes atoms stick to each other because they share electrons, but they don't share them in any kind of rational way. You know, the electrons moving through all kinds of directions and paths, and it doesn't, you know, again, when I heard that as a kid, I said, well, how can that hold things together? If the electron keeps going all over the place, and I was thinking of it magnetically, and you know, like what would magnets do? And clearly it seems like, well, if the magnet's way over here, the one that's repulsive, then why would this thing hang around and wait for it to show up again? You know, it's got no interest in doing that. The magnet most of the time is not anywhere close to the other thing it's supposed to be sticking to. So how can that be gluey? That's not going to be gluey. Just leave the magnet where it is. Because magnets will do that, right? You know, you can take magnets, and if you prevent them from flipping over, put them all on the same face, you can push them all over the place by, you know, having them repel each other. And so obviously you can create repulsion between electrons, and you have attraction to the proton, and you can have a tension between those two forces. And clearly you can also understand that mechanisms change as you get very, very close to something. There would still be enough force leaking in to create a pressure that would keep it a distance from the protons and the neutrons and the other charges. So you don't need complex orbits. You don't need all this stuff you can't explain, because it's a tremendous amount of energy you'd have in one single electron moving at this preposterous speed. And you can't manage it, can't imagine how all that complexity could create something as simple as a photon. No, it doesn't. It doesn't fit. It doesn't. It's not workable. And like I said, it's like they didn't even try to do the simple answer thing. And when somebody showed up doing it, like 300 years ago, they did have a conversation about a simpler model for gravity. And they just find reasons to not believe. Instead of trying to say how they can make it work, they just find reasons to say it doesn't, and run away and just say we don't like that answer because it's too simple. It's anti-God, and that's all this is too. It's anti-fun and fascinating and all that crap, and it's insanely deterministic in the sense that, oh yeah, this is what's deciding who the felk you are. I mean, you're not a magical organism. You're some sort of thing being controlled by a bunch of bits. Just like people don't want to think they're controlled by chromosomes, when in part they are. So anyway, it's enough of a premise, I think. Just get to the point that all that they're saying is just a story. The evidence they have for it is tiny. I mean, these are vague footprints in the mud, and they've made this story that it's 3 bears and the bear's smoking a cigar, and there's, they've got a whole story based on this little bit of evidence, tiny amounts of evidence. And yes, we're both stuck having to work with the evidence that exists, but I'll admit that I'm constructing the better model, and I'm doing it more consistent with that evidence rather than aggrandizing the evidence and making the evidence seem like it's more than it is. So that's a good enough starting point.
Welcome to ElectronLine. Trying to find an explanation of what a photon is, let's go take a look at what a photon can do in an atom. So let's say we have a hydrogen atom here. We have a single proton that's the center, the nucleus, and then we have what we call energy levels around the nucleus. And typically the electrons in the atom will reside in the innermost energy level. They want to be in the lowest energy state. And of course, in a hydrogen atom, there's only one electron, and that electron will usually...
So I would argue the explanation for energy states would just be the pressure that paddles are in. And you maybe could understand that the further away 2 paddles are, the cycling of energy, back and forth, would produce a certain amount of pressure. And then as you bring them closer and closer, the cycle becomes more extreme. And that it also becomes obvious, in a sense, that the number of little bits between you becomes more and more critical to that pressure. So at a big distance, I could have lots of them going back and forth, creating a pressure, because that's the 2 things that are going to matter, right? You can sort of understand that if I have only one ping pong ball bouncing back and forth, there's only so much I can do, especially at a distance, in terms of creating pressure. But if I add more, I'm always going to multiply the pressure, in a sense, double it, whatever it is. So wherever it was here, it's going to double at this distance and double at this distance. It's going to create pressure commensurate or equal to doubling the distance. So doubling the number doubles the distance. So you can understand that one tiny bit, one ping pong ball, is going to always have an effect. Now if there's 150 of them in here, the effect is going to be a lot less in terms of a pressure change. But the point would be is it's always going to have a proportional effect. And depending on the atom, the number of electrons, and the number of bits bouncing between them to keep them, to have the pressure they need to stay intact, that percentage will change. And so, but it's always going to be kind of proportional. And like I say, it's going to be really critical. The closer the paddles are, the more critical that number becomes. All right. I think that's enough. So that's all these orbital levels can represent, meaning it's just a size. if I change the size of the atom, that is the distance between the electron and the proton, then I'm going to change the pressure between the electrons, because now they've got to be closer together inside. And if I can't do that, that is, I can't make them more repulsive, then I have to remove pressure. And if I'm removing pressure, I'm essentially removing a ping pong ball between them. I'm saying if I want them to be closer together, say if I have them this far from each other around a nucleus. If I want them to be closer together, all I have to do is remove the pressure between the electrons to make them closer together. So, and if I change the size of one atom, then I'm going to change all the other atoms, because even in atmosphere, the atoms are communicating with each other. They're connected to each other. That's why this sound thing is working. It's because the atoms do interact with each other. So if I change the atom size of one atom, I'm going to, in a sense, change where all the other electrons are positioned. So whatever change I make, it's going to travel, okay, in the sense that change travels in the nuclear world. You change one thing, you're going to change maybe a lot of things.
Be situated inside the innermost energy level, that's the K level, the K shell, where we have the S1 orbital. Now the energy level of that first level in hydrogen is at minus 13.6 electron volts. The second energy level is at minus, I should say minus.
So, again, this is where they've made this kind of silly distinction. They don't, they've gotten it wrong. So they really don't understand that the two forces are real forces. So when they say minus, they're saying yellow force. That's all they're saying. It's not some sort of minus voltage. It's really a plus of a real force. But anyway, it doesn't matter. There would be probably, if you were to start over, you'd come up with a designation that recognizes that there's plusness of two different forces, not a true minus.
3.4 electron volts, and this should be the third energy level is at minus 1.51 electron volts, and the fourth energy level is at minus 0.85 electron volts. So in order to get an electron...
So it just means that when you add a ping pong ball, it's a whole amount of pressure. So if I have the two paddles and I have 15 balls bouncing between them, and I take one out, I let one go, that 14 is a jump. It's not going to be, it's a standard jump depending on how many balls are between it. So that's all you're really saying is a normal level is sort of defined by how much pressure, and the fact is you remove one, it's a standard amount of pressure that you're removing. So that's why it appears to be some sort of quantum jump, is because each ping pong ball between electrons is a distinct amount of pressure proportional to how close they are to each other. So the further away, the less well, it's hard to say, the less percentage of distance it'll make a change. So the more ping pong balls there are, the percentage changes. But the fact is, all these atom nuclei and the rest of it is pretty standard stuff. It's built inside of suns. It's built to be durable. They don't, the atomic structure is difficult, not easy to change the number between them. And so there's a standard, and this is the standard geometry. So through nature's doing trial and error. It's doing an evolution experiment inside of suns, creating a great deal of pressure, and there's certain configurations that the magnets get into, the little magnets, the little magnetic monopoles of electrons and protons, and they get into certain arrangements that are really good. And just like you could put magnets around each other with in between a piece of glass, and you can put them in an arrangement and it'll make a hexagon, and the hexagon will be very durable. No matter which side you push on, it'll always sort of reform the same shape, and it won't shape into something else. And that's why there's only 100 or so, well, 90 or so natural elements.
electron, let's say from the first level to the second level, you have to infuse a certain amount of energy. How much energy? The difference between the energy level of the first and the energy level of the second level. So what would be the difference between 1 and 2? So the delta energy going from 1 to 2 is equal to minus 13.6 electron volts minus a minus 3.4 electron volts, which is equal to a minus 10.2 electron volts. Now, of course, that depends which direction you go. In other words, if you want an...
So this is just an illustration that the mathematics always does reduce to something, which is great about this guy's videos, Michael, is that he actually solves equations. He doesn't just sit there and give you some statement saying, yeah, it works. You know, he actually does put the numbers in. You can see the numbers are just numbers, and all you're doing is plus and minuses and multiplication and division. It's nothing all that fancy. So for all these people who think this math is some sort of magical thing, it's not doing anything magical. All right. So what else has to be said? So really, so when he says this will release a photon, or this puts in a photon, it's not really a photon. Now we're back to the photon is described as these little arrows. One little arrow, one piece of a photon, one piece of the frequency is created by the jump, not the entire frequency. So there's not a whole ray created by a jump. There's only one element of what can become a ray that'll leave the substance after a few atoms do the same thing. But more than one atom has to do it to create the elements in a row. So this is where the vocabulary that isn't too good fails to make the physics understandable, because the word photon is being used when what they really mean is element of a photon. An element of a photon is released from the atom, not the entire photon. It needs to be constructed out of the same process happening more than once.
Electron to go from the first level to the second level, you will have to give it 10.2 electron volts of energy. And if an electron goes from the second level back down to the first level, it will give off a 10.2 electron volts worth of energy. So in order to move an electron from one spot to another, from one energy level to another, it needs that amount of energy. Where does the energy come from? It can come from photons.
So the argument would be is that all of this is based on their model. So these constants that are put in here can be changed based on changing the model that they're using to describe these effects. The fact is they're probably right in terms of getting the proportions right, but the explicit numbers might not be right. How many of this elemental stuff is required to make these changes is where they're lacking a specific evidentiary model. I mean, the evidence. They don't have explicit knowledge of how much of a ray a photon is. They don't really talk about ray lengths, about photons. How much energy is actually in the thing they're calling a photon.
For example, a photon can come along that has the exact amount of energy. How much energy? Exactly 10.2 electron volts. If it does, that electron will absorb that photon and use that energy to jump to the next level. If after a little bit of time, maybe 100 millionth of a second.
So again, the energy level again isn't being described by the fact that it's individual arrows. Okay, they're talking about energy in the concept of it has to hit at a timed interval. So they're calling energy the interval. How close are the arrows close to each other? Not how much energy each arrow contains. And that's the big flaw here, is not recognizing that the interaction is an interaction of, again, having to put energy into a system. You have to put energy into the electron, and it takes more than one impact to create the momentum necessary to make the jump. So it does have to be hit by more than one. You have to inject more than one to get it to be forced into the pattern. So it could be analogous to you have 5 electrons, in a position around something, and then you add a 6th one, and that pressurizes all the others and expands that orbit. So where they have the orbits fixed, I would argue the orbits aren't fixed at all. The orbits are actually changing sizes based on what you shove in between them in terms of energy. So if you add energy, say you stay with 5, but you add energy into those 5, you trap more ping pong balls between one set of paddles. That energy will be felt by all the others, and they'll have to adjust to that new amount of energy, which means they'll expand.
Or so, it decides to fall back down to innermost energy level. It will then give off a photon of that exact energy level. So it turns out that photons can interact with electrons.
Alright, so it turns out they can interact with electrons, but what he didn't draw in the model is the fact that the electron's moving 400,000 meters per second in this, insane speeds that it's traveling at, and that it's not traveling in any plane, that it's going all kinds of different directions, and it goes into all kinds of different loops and patterns of where it doesn't even know where it is, kind of. So, when they're when they want to say something simple, they draw it simple, but that's not the context. They're not working with some kind of simple system. They're working with the rest of their story is a whole different story. So one minute the gremlins have 3 legs, and the next minute the gremlins hop around on a pogo stick. I mean, they change the story to suit what they're arguing for.
They can hit an electron and make it move if it's not in an orbit, it's just out in space, or if it's in an orbit of an atom.
So again, this idea of electrons just roaming space doesn't really have much credibility. There's no evidence, that you can go out and find something called a free electron. They're charged. There's going to be more of one kind of thing closer to them than there is on the other side. There's always going to be an imbalance of some kind. You can't, just we're stuck on the Earth because of it. Electrons have the same problem. They can't just float around somewhere and say gravity's all the same. No, if I threw you in space and gave you absolutely no motion, you'd end up pretty quickly going in some direction, because there's going to be mass closer to you one way than there's going to be mass close to you in another way. There's going to be an imbalance.
Photon could come along, and that electron can absorb that energy of the photon and use it to jump to another energy level. But the jumps have to be quantized, because if the amount of energy in the photon is not exactly equal to the difference between those 2 levels, the electron will not absorb the energy and will not make the jump.
So the real critical part, it has to be at the frequency fast enough. So again, this is, they make it sound like it has to be a specific thing, a specific amount, when technically all it really has to do is be faster. The faster energy or slower energy. So slow energy won't work. It has to be fast energy in the sense that it has to have a high enough frequency. So the photoelectric effect works at one minimum level, and they'll say that's ultraviolet, but it works just as good at X-rays, and it works really good at cosmic. So the faster you make the energy, the more reactive it is. So it's not like it needs it to be just this much and nothing else will work. It's just really saying that the energy has to come in, like moving something, like pushing a car or out of the snow or something, that the energy has to come in the right way. You have to push at the right timing level. So it's really just about timing, and the real important thing is that it's really faster is always more likely to create a reaction than slower. So it's like trying to compress the trampoline, and you're going to hit it with paintballs or whatever, some sort of things at a momentum. And you can just logically know that if you give the trampoline time to compress back in, okay, that you're not going to be able to push it as far. And the faster you shoot, the more likely you are you create a deeper impression. And the key is you have to create a certain impression to create this effect. You have to keep hitting it to move it from one place to another. And if you stop hitting it for just a second, it'll bounce back. That's the key word. It's in tension, and you have to hit it fast enough to defeat the tension.
Likewise, let's say we have an electron that is in the 4th energy level, and for some reason it jumps all the way down to the 1st energy level. It can do that. Sometimes it jumps one at a time, sometimes two at a time, in all kinds of different situations.
So again, he's sounding like it's almost some sort of random idea, but no, that would require a certain ray length, you could argue. So this is where it gets into the whole argument about how long these things are. Not just that they're fast enough, but that you have enough of them to keep pushing. So the argument I would make is that you need photons of a certain intensity. That is, that they have to have you have to make sure that the little bits are so dense that you have a bunch of them lining up right behind each other, essentially, so that what one photon does, the second photon continues to do. So it's like you have to have enough cars that you have cars essentially drafting behind each other, and it's only when you have 2 cars in a row, or 3 cars in a row, that is, cars being photons themselves, that you can get that deep, that you can make that big a jump.
It's kind of like marbles falling down to a lower level, and sometimes the jump can be in one jump. So what would happen if an electron jumps from the 4th energy level down to the 1st energy level? It would give off a photon of that exact energy difference. So it would be exactly the difference between 0.85 electrons.
So when he says energy difference, he's really saying frequency. So it would create a very, very, very narrow frequency. But again, we're just talking about how much it's going to rebound. So you can, if you push in enough on the trampoline, then it's going to rebound, with a certain momentum. And the whole basic idea is converting the momentum, the movement of electrons. You're basically moving electrons, the heavier thing, okay, creating a momentum in them, and then converting that momentum back into photons. So the whole idea, I would argue, about what a photon does is that it hits a crystal in the metal. So there's a crystal in the metal or in the glass of a certain size, whatever, 10,000 atoms. And what's happening is that if you keep hitting the crystal, in different locations, but with that frequency, that is, you hit once here and then you hit once here exactly a millisecond later, and then 1 millisecond later you hit here, those collective vibrations in the crystal will be interpreted into the motion of an electron, and that motion of the electron will travel through the material, get to the other side, and essentially do the same thing. It will cause the other side to move, which will cause the electrons on its surface to go away from the material, and when they rebound back in, when they bounce back, is when they create the photon again. So in different locations on the crystal on the other side, the same thing will happen in reverse, in the sense that it will be pushed out of position, and the electrons are going to go back to their position, and when they go back to their position, they're going to create the same pattern that was created on the other side. So it's a conversion of the force bits, their speed of light momentum is converted into motion of electrons into each other based on paddles, ping pong paddle, ping pong paddle, ping pong paddle, with stuff in between. You move one paddle, the other paddles will all move, and then that paddle at the end has ping pong balls bouncing off of it, and it's going to move out and move in, and when it moves out and it moves back in, it's going to release the frequency, in the sense that it's moving its position, which means it's going to change how stuff reflects off it to the universe, and it's going to create this frequency again. I'm saying this is really simple physics, right? 2 plus 2 plus 2, but it's not. You can't explain the universe with just ABC blocks. It does. You all have to spell words, and it will get a little bit complicated. It's not going to be just nothing to create complex things. So when things start getting in patterns and arrangements, yeah, there's going to be vocabulary, but it's not going to have their vocabulary. It's not going to be full of bizarre creatures. They're going to be understandable, but I can't make it ABC.
volt and 13.6 electron volts. Since we talk about the difference, we just talk about the absolute value between the two. So let's calculate what kind of photon would be generated or would be needed to make an electron jump from the first level to the second level. So we need a photon with this kind of energy. So the energy of a photon, we know, is equal to the h constant times the frequency, which is equal to h times c over lambda. So the wavelength...
So let's understand that, again, this is a flaw in understanding the real energy, because they're measuring the energy based on how fast you have to hit a trampoline to dent it. There's probably a better example. Well, we're back to a pendulum swinging. You know, I could have a pendulum swinging at a rate, and the faster the pendulum's swinging, obviously the faster rate I have to put the energy in so I can make sure I don't hit it when it's moving against my motion. I want to keep adding energy, so I have to add it at exactly the right frequency, and they're calling that energy. So they're saying that because the pendulum requires a certain frequency, that frequency is energy, when no, the real energy is in the clumps, and it is only the trampoline, or only the elastic material that's going to move back if you don't keep hitting it. It's the elasticity of the material that's defining what they're calling energy, because they're saying what affects an electron. They're not saying what is the absolute energy of the photon, the little bit moving the speed of light. What's its capacity to exchange momentum? They're saying its capacity to exchange momentum is completely related to how it affects electrons. So I'd argue that that's not getting it right. It's not a pure description of energy, and so you have to understand it in that context, that they're going to change the numbers of what the momentum actually is because it has more of an effect on trampolines. So they're defining trampolines as the standard for what energy is, or elastic surfaces, instead of defining it based on what change in momentum is it actually making. Because the real energy is going to be heat and a lot of other things it's going to create. So this little bit, they're only counting it based on how it moves an electron, based on how it changes the position of an electron, not based on how it moves the electron. So the real answer has to include all the other effects that the energy bit has, which is heat and all this other stuff. But they're only counting the energy that's relevant to electrons.
Would be equal to hc divided by lambda, by energy. I want to put the energy there and put the lambda there, so definitely what I wanted to write down here is...
I should have said it's always based on the interaction with electrons. The more interactions, the more energy. And the only argument being made is as you increase the frequency, you increase how fast something's moving between two things, because you bring the surfaces closer together. Obviously, you're making more energy in the sense that you're creating more interactions. So the reactions are always with photons. I'm just saying their standard is they're measuring it based on how the paddles move, rather than on how much... that's not even the right answer. They're basing it based on what the atom, how the atom changes, rather than how the electron changes. I guess would be the right way to say it.
Energy, not lambda. All right, so let's plug in the numbers. That would be 6.626 times 10 to the minus 34 joules times seconds. Multiply times the speed of light, 3 times 10 to the 8 meters per second. And then we divide that by the energy required, which was 10.2 electron volt.
I mean, it does get kind of redundant, but the great thing about it is that you do start to remember this stuff. You know, if somebody says 3 times 10 to the 8th enough times, you say, okay, that's the speed of light. I got it now. It's stuck in my head. 3 times 10 to the 8th. So that's the good part of it.
And of course, we want to convert from electron volts to joules. That would be 1.6 times 10 to the minus 19 joules per electron volt. All right. 6.626 e to the 34 minus times 3 e to the 8 divided by 10.2 and divided by 1.6 e to the 19 minus, and we get 121 point, wow, I need my glasses for that. 121.8. So the wavelength would be equal to 121.8 nanometers, which of course would be a photon of ultraviolet light or
well, it's a weak X-ray, you could almost argue, but it doesn't really matter. What else is there to say about it? Yes, but this is the point is that all you're really doing is saying how hard is it to how fast do you have to hit something before it rebounds. So the electron is in tension, and you're just saying I'm going to move the electron from here to here, and the only way I can make it go into this other orbit, this other collection of electrons that are under pressure, is I have to push it before it moves back. So I have to push fast to get it to there. And that's what they're measuring as the energy required. They're not really counting just the number of things hitting it. So you can't just say, well, that equals 5 bullets. It doesn't equal 5 bullets because they're measuring how fast the bullets were shot as the energy. So that's where this math fails, in my opinion, just because of the fact that it's now called energy specific to the tension of electrons inside of atoms. That's the new quanta, when the quanta was just this arrow before. And you could argue that there's a time factor, and that so if you use the time factor to say these arrows at a specific amount of time, then you can make an argument that you've stayed consistent. But this isn't consistent. Making frequency explicitly momentum is a mistake.
Ultraviolet radiation. So if a photon of this exact wavelength with that exact energy, 10.2 electron volts, comes down, strikes an electron in a hydrogen atom in an innermost energy level, that photon would be absorbed and the electron would jump to the next level. And likewise, if an electron...
So when they say absorbed, again, the argument is that these little bits can never absorb anything. They can only exchange something. So they're always going to give something back. These are boats, essentially, the electrons and protons in a sea of swimmers, you could argue. And the swimmers jump in and become rowers. But there's only so many seats in the boat. So when they jump in to become a rower, they kick somebody out of the boat. And that's what I would argue is the real science here. The real evolution story. The real mechanics. That's the real DNA molecule, kind of thing. See, Darwin had lots of theories about how our heritage was stored. See, he knew our heritage was stored, right? I mean, that's an obvious observation even 200 years ago that, yeah, you look like your mother and your father, some kind of weird perversion of the two. And you have some resemblance to your grandparents and all this kind of crap. There's something similar about you and your lineage. But he had no idea where that information is stored. He just knew it had to be there somewhere. It's somewhere in us. But he didn't know that it was stored in a little tangled molecule of glue.
Photon falls from the 4th level down to the 1st level. What kind of photon would it generate? Well, the difference in the energy going from 1 to 4, that would be equal to 13.6 electron volts.
So it's just momentum, really. All you've done is change the momentum potential of something by moving it from one place to another. You've crowded one place or thinned out another. You've expanded an orbit. You've contracted an orbit. It doesn't really matter how you've just changed its position, which means that it can convey that new pressure to anything that bangs into it. It's going to feel the extra pressure. So if one atom that has this energy has gone in and expanded it, okay, hits something else, that extra pressure is going to be felt by the something else in the sense that it's a tighter rubber band. And it's going to convey that extra pressure to the thing that hits it. So the atoms will communicate this extra pressure. The electrons really will convey to each other that I'm a high pressure, ping pong paddle, will be conveyed because they're vibrating. The paddle vibrates, and that vibration, when some other electron gets close, the vibration will also be felt between the number of little force bits bouncing between those two electrons will essentially vibrate at the same rate that the thing itself is moving, and it's going to now gain that extra vibration. And the vibration is essentially a form of the momentum. You're imposing momentum more quickly. You're having more interactions, more swimmers jumping into the boat and making exchanges. And the more that happens, the more likely you are to head in the other direction. So it's just conveying one form of motion at the speed of light, the swimmers, into motion at the slow speed that electrons can move.
Minus, let's see, the fourth level would be 0.85 electron volts. And again, we're just looking for the absolute value between the two. So this would be equal to 12.75 electron volts. Yep, that would be correct. So converting that to a wavelength, we can say that therefore the wavelength would be equal to hc over energy, which is equal to 6.626 times 10 to the minus 34 joules times seconds.
So again, he could have just approximated it based on his knowledge of the fact that there's a proportional relationship, and so he could have just said, I know it's going to be 1/3 the amount, or 40 times more, or whatever.
Multiply times 3 times 10 to the 8 meters per second, and dividing that by the energy, which is 12.75 electron volts. And of course, convert that to joules, 1.6 times 10 to the minus 19 joules per electron volt. And so we would see then what kind of...
So, they could simplify this, I suppose, by... I mean, it's almost like you're not saving any time by writing all this crap when you could just say 1.6b or, some other term to satisfy that condition. But whatever.
Photon would be generated when an electron jumps from n equals 4 level to n equals 1 level in a hydrogen atom. So 6.626 e to the 34 minus times 3e38 divided by 12.75 divided by 1.6 e19 minus equals, and that would be a photon with a wavelength of 97.4 nanometers, which is 10 to the minus 9 meters. So there's another interesting look at what a photon is. A photon is a chunk of energy that can be responsible of being absorbed by an electron and therefore making a jump to a higher level, or it...
So he could have said photons are energy at a frequency, and the frequency can affect things in tension. So if I put an electron in tension in an atom, that is, I make it attracting and repelling and so stuck in a position, that it takes a certain amount of, and a certain you have to finagle it out of that tension, and the finagle is completely dependent on frequency. So I can come in with a ton of energy, as the universe is doing to you right now. It's hitting you with a bunch of stuff, but it's not stuff that has the right recipe, the right hitting at the right moments to cause all of your atoms to break into pieces and to force all this stuff to be moving in this way. So the atom itself is rigid, is strong, but if you hit it, you take, a good example is medieval days, right? They took a big giant tree, and put it on ropes, and then they smashed it into things to smash through. It's kind of a similar analogy. You have to hit electrons to move them substantially. You have to break them free, and to break them, you have to hit them, with a certain frequency, within a certain amount of time, to prevent the relaxation, the movement back. And so you have to hit them deep, and you can only do that with a certain frequency. I mean, his explanation is, again, he's asserting that they know something when they just know, they know a few little pieces. And that's it. They're just little, vague, pieces. There's a tiny bit of evidence that we're following. And they're following it to this whole big convoluted story. And I'm saying, no, the evidence is not as complicated as they're making it. They're taking a crime scene and they're making it into some mass conspiracy theory. So it's almost like, so you can almost compare them to 9/11ers or something. They take a tiny bit of evidence that's out of place, out of context, and they turn it into a whole elaborate story of how everybody's out to get us, and they fake the moon landing, and there's this whole conspiracy of reptilians who are controlling the world, Jews. And, you know, they turn into this whole phantasmagorical bullshit story.
Can be a chunk of energy given off by an electron when it jumps from a high level down to a lower level, to a low energy level, and then releasing a photon with that exact energy difference. That's what photons are. Photons.
So I would argue that it's more complicated than one atom, and but whatever.
Are carriers of energy, and that energy, when it arrives somewhere, can be utilized by electrons to do something with it, or if an electron jumps to a lower energy level, it can give off an electron with that particular.
Right. So you could say, well, look, you know, there's only these specific little, you know, specific arrangements, patterns, specific patterns of energy can cause specific effects. And so we could assume that there could be lots of energy that isn't in that pattern, and that there's lots of energy in the universe, okay, that we're not recognizing because it's not doing this to an electron. And we need it to do this to an electron for us to recognize it, to see it, to make an instrument that can detect it. But there'd be a ton of this stuff that, you know, we wouldn't be detecting, and that maybe that's your bent geodesic. Maybe that's the thing that's pushing the Earth into the sun. And now you can have one force instead of four. And again, they don't have just four forces, obviously, because they have a field for every single particle. So they have some 400 fields that they say are all different and distinct in space. And that somehow these fields are being controlled by some tension that they don't have an origin or a mechanism for. And again, it's not 400 fields. It's not 400 elemental bits. It's only two. And there's two kinds of matter. The ones we know are always in play, protons and electrons, neutrons being a composite. Everything else is a composite. And then all you have is this force and these electrons and protons. And yes, you can move electrons fast and it'll look like something different. You can move a proton fast and it'll look like something different. I mean, that's all they have for their positron, is the fact that a positively charged particle moved too fast. It was moving too fast for them to think it was a proton. That's it. There's nothing else. That's the evidence they have, and they give it a new name. But all you have to do is move a regular proton fast, and you have what looks like a positron. They're seeing something move in gravity, and they're saying it can't be this this heavy thing because it was bent too little. So, you know, the velocity versus the mass argument, and so its mass doesn't fit what they think its velocity is, and that's all. They're saying they couldn't move mass that fast with the energy they put in. So they're saying it can't be a proton because protons are too heavy and I can't make it go fast enough to bend that amount. The speed decides how much it bends. They can't measure how fast it's going, but they can make assumptions about how big it is. And so their assumption about how big it can be is basically telling them, well, to bend that little, it must be something smaller. And no, it can be something bigger, just moving faster. Well, anyway, I don't want to get into all of their wrong assumptions, but it's a tiny bit of evidence. It's the fundamental argument of this channel, is they're so arrogant that this is the right model, and it's based on so little evidence, and it's such a messy model. It's so convoluted, and it doesn't have to be. There's a simple answer, and they're just ignoring. They're just pretending there's no other possible model. And it's just an evil assumption.
Photon with that particular energy. Even any kind of quantum jump in quantum mechanics, any kind of particle that goes from one state to another state, if it's from one...
Yes, it isn't going to be jumping. It's not going to do anything outside the boundaries of what we know to be the limitations of these particles. These particles do not quantum jump in the sense that they say the word, where they just magically change. No, they have to be pushed. All right, and pushing takes time. It never quantum anythings.
One energy state to a different energy state. If it goes to a lower energy state, it will give out a single photon with that energy difference. If it goes to a higher energy state, it will absorb a photon of that exact energy difference.
So really all that's really we're talking about is how fast it's vibrating. So when it's in the tighter, when the ping pong paddles are closer together because there's more pressure, they're vibrating much faster than they're vibrating when the paddles are this far apart. And that's really all it is. It's the number of interactions. The interaction speed is much higher when they're closer together, much slower when they're further apart. And the interaction speed you could convert into a frequency fairly easily in terms of it will decide how fast something leaves between those two paddles is going to be decided by how short the distance is between the two objects. You can empty two ping pong paddles. Like say if I just tilted them this way, right? So I have energy trapped and I tilt them this way. If I tilt them this way when they're really close together, all the stuff's going to leave at a high frequency. If they're way far apart, it's going to take a long time for the stuff to leave. So how much time it takes to release the energy changes based on how close the electrons are to each other.
And that's how photons allow these things to happen, because it gives the material, it gives the atoms, the electrons, the protons, the quantum mechanic particles, it gives them...
It's the balls between the paddles. Photons are force. They are not something else. They're the little bits moving the speed of light. They're a force. These are the players. The electrons and protons are the matter, or the boats.
What they need to exchange that energy to allow them to make those quantum jumps. So photons are basically the facilitators of quantum jumps in nature.
Yes, so the word photon, again, is the word used, but the photon is gravity, the photon is magnetism, the photon is charge, so we really should have some other word for it. Force bit, something, okay, something replacing the word force bit, but that's what it is. Force bit at a frequency, force bit not at a frequency. Again, that's all it is. It's all one thing, stuff moving the speed of light that carries a momentum of 1, and that's all you have, and that has an implication in the sense that obviously when I trap that stuff between paddles, I can change how many interactions take place, period. And that's frequency. All right. That's all I can do. I can only provide you the reasoning. I cannot make you reasonable.
Another look at photons.
All right. So the simple argument is there's an evolution theory. You don't need these dogmatic narratives that force you to consider wormholes and infinite wells and singularities and, you know, magical transportation of information and all this absolute woo. And it is woo. It's a religious story, completely dogmatically stated by these preachers. And it's just as bad a theory of reality as religion was when it was invented. But the argument I would make is religious people were, 2,000 years ago, people were stone cold dumb. I mean, they were ignorant. They're not ignorant now. We've seen humans make mistakes. We've seen the errors. We've seen plus be put on the wrong thing and minus be put on the wrong thing. They've seen the mistakes. They see how easy it is to make mistakes. They see how religion was invented and we still can't shred ourselves of this ignorant, silly fable. You know, centuries later, people still are suckered in by this stupid storytelling. They've seen all that, and yet they're behaving exactly like it. They're doing exactly the same thing. They're jumping the evidence. They're jumping their own knowledge base. Just like those ignorant people of the past just didn't have any knowledge of anything, and they just started making up stories about gods in the clouds and, you know, blights and gremlins and demons coming to ruin their corn crop or some other bullshit story, okay, that only a person, an ignorant person, makes up a silly story. Why are these people making up silly stories? And they're silly. Shit. Alright. Like I said, all I can do is attempt to reason with you. That the correlations are obvious and apparent. The mistake of jumping evidence. The mistake of not being thorough enough. You know, not really founding your notions of a Thor god. You know, by doing some experiments and figuring out, maybe you can figure out what this thunder thing is and this lightning thing is if you experiment on it for a while. And they almost hate fundamental experiments, simple experiments. All they want to do is do experiments that look like God. You know, it's like the electric universe. They just want it to be pretty colors. Look at all their universe pictures where they've colorized all of them. Why they do that? Because that's what they're looking for, is pretty pictures. They're not looking for the truth. Shit. Anyway. Till next time, such. I can only do the right thing. You continue to do the wrong thing. I mean, there's only so much I can do. I can, you know, wish you slip on banana peels, but I really can't do much. Stop being an idiot.